Okay, so we're gonna go over the problem number 1. They wanna forecast next 4 months. They noticed that demand on December was pretty bad because of bad economy. This is showing that most recent data is more valuable. So we're gonna use the exponential smoothing. Before we do it, we need to visualize the data first. So this is showing that it's kind of showing like constant. Oops. It's pretty constant. So we're gonna use the constant exponential smoothing. So first thing, we'll have to find the alpha hat. Alpha hat is going to be 2 over n plus 1, which n is 12, as see here. So it's gonna be 2 divided by 12 plus 1, which will come out 0.154. So we're gonna create one more column here. Weight. So here we use 0.154. The formula that we're gonna use is alpha hat times 1 minus alpha hat, so n minus 1. So this one will be which is 0.13. If we calculate the other ones, it come out as 0.11. So as you see here, we're going backward. So in here, this one was 0.154 times 1 minus 0.154 and minus 1, which was 11. So once we got when we sum up this one, it came out to be 0.866, which is not 100%. So we have to normalize the weight. So how can we do it? We just have to divide it sum, weight divided by the sum. So let's make one more column and say norm weight. So let's just do the one of them to see how we do it. So 0.154 divided by 0.866, which is 0.178. So let's do it for the other ones too. Divided by 866. .151. Okay. Okay, these are the outcomes. So now we have to normalize the demand. It's simply just multiply by normal weight multiplied by the demand. Normal demand. So for this one, the demand was 10,100. We multiply by normalized weight, which is 0.178. So it came out to be 1796.93. So we do it for the other ones too. So for period 11, it's gonna be 2062.61. For period 10, it's gonna be 1469.6. One more 3. So we keep on doing it. As you see here, the weight of the last month is higher than any other period, which is showing that very last month has the more weight than other period. That's what we want. So in here, we normalize the demand. We will sum up this one. So sum up everything, add everything together, it comes out to be 125.4. We can round this up to 6. So next 4 months, which is demand on period 13, will be 12,306. And since, so this is about, we can say this is about, let's change the color. This is about 26. And since it's constant, demand for period 14 will be same. And demand for period 15 will be the same. Okay, we'll be move on to the problem number 2. It specifically says use the constant exponential for this one. But we still wanna visualize it to see it. We can estimate the average value without calculating anything. It's gonna be around around here. If we visualize and see it, we can see that when we calculate the value, we can see that it's right or no. We get an answer. So here's your data, actual data. So we're gonna use the same thing but a little differently. Let me give you the formula first. The formula that we're gonna use is this one. So let's calculate the alpha hat first, which is 2 over n plus 1. And 2, and was 4, which is 0.4. At period 1, d hat is 80, same. On period 2, we're gonna use the formula. So alpha hat was a 0.4. Current dt is current 1, so 50 plus at next one dt minus 1, which is previous one, 80, and it come out to be 68. And move on to next one. Oh, here has to be negative. So 6.80. There's a reason that we did it without normalizing anything, because on the problem B, it's asking what is the bias for part 1. Okay, so wait, for A, average is 74.08, so period 5 or 6 it's gonna be 74.86. So let's write on here A, demand on 5, 74.08, demand on 6 will be 74.08. So it's similar to what we draw in here. It's not all like a straight line, though. It's kind of similar. So we can see that it's about right. So let's go to B. So on period 1, 2, 3, 4, actual demand was 80, 50, 90, and 70, and then expected demand was 68. Oh, never mind, was 80 on 268, 377, 77, and 75. Bias is simply difference between calculated demand and actual demand. So difference between these two is 0. And here's negative 18 and 23, negative 5. So it's just showing that we're overestimated and this was underestimated. Oh, I went the other way. Okay, 23, 5. So period 2 was 18 overestimated, Period 3, 23 underestimated. Period 4, which 5 overestimated. We wanna know the average of this one. So which comes out to be 0. So we can say this data is really reliable. Let's go into C. It's asking what is the mean square error. Now we need to square these values. So we already have data right there. So let me write this one first. So mean square error is sum up the expected demand divided actual demand square and divided by n. So which is 80 minus 80 times square. So 175.60. So mean square error was 175.60. Okay, we're gonna go over the problem number 3. They wanna purchase 15th year. So on T here, it says each year. Just looking at the data, we can see that demand is increasing every year, but we'll have to visualize it first, see if it's true. So here's the graph. So we can see that it's going up, and it's not saying anything on the problem. It's not saying anything about the listen data, which means we're not gonna use the exponential smoothing. We're just gonna use the linear regression. So there's things that we have to calculate first, which will be the dt, just simply d times d. So 1500 times 1, which is 1500, and 2100 times 2, which is 4200. Okay, let's go ahead and calculate the last of those. So period 3 is gonna be 5700. Period 4, 900, 9000. Period 5, 11,000. Period 6, 18,725. Period 7, oh wait, I missed something, so let's go back and do it again. And now we need the t squared. Just simply period power by 2. So 1. So next one, 19, 16, 25, 36, 49, 64, 81, 100. Okay, so now we got all the data that we need this. We need the average of demand. So which is D hat. Divided by n, which is 10. And it come out to be 2612.1. And with the sum of t square, which is 25. And we also need the sum of dt. dt. Like this. Okay, first thing we need is b hat. That's sum of dt negative n times d hat times d bar times t bar, and sum of t square minus n times t bar square. Okay, we don't have a t bar here. So t bar is gonna be 5.5. Okay, we have all the numbers, so let's plug this in. So 16,212. What was it? Okay, anyway, so dt negative n was 10. D bar as 2612.10. T bar, which is 5.5, and divide that on by sum of t square, which is 385, negative and 10 times t bar, which is 5.5, and square. So let's calculate this. Okay, so I got 232.08, and now we got the B hat. We can calculate the A hat. A hat is D bar minus B hat times T bar. We already got the numbers, so is 12.10 negative P have is 222 and 5.5. Okay, let's calculate this. It's gonna be 1335.67. Okay, so D hat, this is the formula. We are interested in T15. So T hat 15 is gonna be A, which is 1335.67 plus P hat, which was 222.08 times T15. Let's say it's going to be 4816.87. So expected demand on year 15 is gonna be 4816.87. Okay, next one is problem number 4. Even before we visualize it, we can see that it's gonna be seasonal. So when we grab this one, it will give us like some kind of pattern. Actually, it says in here, so using the seasonal forecasting. So we're gonna use the seasonal forecasting when there's some kind of pattern. So we can see that there's 2+2 period is high and low, high and low, and high and low. So these are pair. So as you be seeing here, we're gonna divide into 4 quarters. The first thing we have to do is we need to calculate the average value, which is gonna be the head. So average of this one is gonna be 108.75, 93.50, 45.25. And then we need the T bar. Let's put somewhere around here. Let's put here T bar. It's gonna be 1 plus 2 plus 3 plus divided by 3. It's gonna be 2. And then we need the it's gonna be similar to the linear regression, but we're gonna use this T bar based on the T bar. So first thing we wanna calculate is same thing as the linear regression. We need the B bar. I mean the B hat. Oh, before we do, let's get some data too. So let's say T1, 2, 3, and D is gonna be 108.75, 93.50, 45.25. So we need the average of this one, average of, let's say average of average. So it's gonna be 550 and the TT 187, 340, 2.75, and then T squared, which is gonna be 1, 4, and 9. and we need the sum for this one. Sum will be 638.50. It's hard to read. So 75. And sum of t square will be 14. Okay, I think we got all the data. So let's calculate a p hat, which is gonna be sum of dt negative n times d bar divided by sum of t square minus n times t bar square. Okay, let's input some data. So we have n, which is 3, n times was 2 divided by 14 minus 3 times 2 square, and it come out to be 2.75. And let's go to a hat, which is gonna be d bar negative p hat times t bar. So 105 by 15 negative 2.75. T bar was 2. And this one came out as 100. Now we have to do is we need to weigh the demand on each period. So at T1 demand was 130, 145, 72, a quarter 1, quarter 3, Q3. We just have to simply divide it by the average value. So it's going to be 108.75. And it came out to be 1.20, 1.33, 0.66, and 81. Okay, let's do for the other period too. And third period. Well, we're gonna calculate average on each quarters. So average of first quarter will be 1.25, quarter 2 1.39, quarter 3 0.71, quarter 4 0.65. So on year 4, we need to calculate demand on 4. It's as 100 times 2.75. Let's keep the formula first. Plus 2.75 times 4, which is 111. Okay, we need to calculate on each quarter. So we have normalized the value. We have a weighted value. So we're gonna use this one to normalize this one. So on the demand for quarter 1 will be 100 times 1.25. Quarter 2 will be 100, 1.39. Quarter 3 will be 1100, 0.71. Quarter 4 will be 0.65. And it come out to be so let's go back to chart, and we can show here on year 4 quarter 1 139, 155, 79, 73 based on the what we calculated. Okay, now we're gonna move on to the problem number 5. It says you've been hired by the McDonald's and they wanna forecast the number of patty that you need on next year. We got the data from past 6 years, so it's not saying anything about recent data, so we're not gonna use the exponentials. The best way to see is graph it as we did before. It's kind of hard to see. It's not going up. It's kind of constant. Let's draw the line on here. It's gonna be around here. There will be some bias because of this point. See the distance from here. If we didn't have this one, it can be looking nice like this, but no. So it's gonna raise some average value. So there will be some distance from here to here, there to there, and here to there. But I think this the constant will be the best option. Since we're not gonna use the exponential smoothing, we can simply use the moving average. So period 1, which was 2005, and 2, I think it's gonna confuse. Say 5, 206, 27, 2008, 9, 2010, and demand was 120,000. Okay, so moving average, simply we just have to add three data from the 3 demand, I mean the demand from 3 period, and just get an average. So here we're nothing here, and here we just add up the 3 demand. Which will come out to be and here it's gonna be, now it's gonna be this 3 point. Oh, let's do it in green. is let's get the different color. So from here to there. And then we want the next one, which is the last one. So we can say that expected demand on year 2011 is gonna be one hundred 122,136.33. So let's round it up. Okay, just so we expect patty that we might need it on year 2011. Okay, let's move on to the problem number 6. Your data is given and it's kindly says use the constant exponential smoothing, and we want to know the demand on the S year. Let's make pretty. Okay, let's copy the data first. So period 1, 2, 3, 4, 5, 6, 7, and demand are 4,000, 4,200, 4,100, 3,700, 4,200, 3,800, 3,900. And we need to know the A head, alpha head first, which is 2 over n times 1, n plus 1. And it's gonna be 2 divided by 7 plus 1, which is gonna be 0.25. Let's move this a little bit. So let's write period demand and we weight it. So as if we did it before, we're gonna go backward. It's gonna be 2.5 and 2.5 minus times 1. So as you noticed here, the last one has to be n minus 1. If it's not, we're missing something. So this R came out to be oops, made a mistake here. Okay, we have to normalize it as we did it before. Oh, we need to know the average of this one. So average of weight will be 0.867. So we're gonna divide everything into 0.867, which will come out to be 0.051. And normalized demand will be just multiplied by normalized weight times demand. Demand times normalized weight. So 이제 25.40, 287.55, 274.27, 450, 35, 61, 26, 20. Okay, we're gonna sum everything up, which came up 3946.64. So expected demand D hat on period 8, right? It's going to be 3946.64. We can round it up to 39.47. Problem number 7. It's asking to use the linear exponential smoothing to find the expected demand on 9s and 20s. Here's the data that's given. So let's create a chart. So period 1, 2, 3, 4, 5, 6, 7, 8. And demand is without graphing this data, we can see that the demand is going up. So we can, even if this linear information was not given, we can see that it's just linear. Okay. So first thing that we have to calculate is alpha hat, which is 2 over n plus 1, which will be and this is 0.22. And then things that we need is we needed dt times dt. But we found a lot of data. Double head. Okay, so we need the initial condition. So A1 will be same as demand 1, which is 2000. We need the B1 head, which is Tm minus D1 minus 1. It's gonna be T and its demand on the last period, which is demanded 8th period. It's 14,000 divided by 8 minus 1. It's gonna be 14.29. And we need the D1 head, which will be A minus B1 head times 1 minus alpha divided by alpha. We need a head here. So 10 times okay, so this value come out to be negative 4077.92. It came out negative because difference between demand on period 1 and demand on period 8, there are huge difference. So this one, this part came out larger than a demand on first period. That's okay because it's gonna get increased as we going on. So next one, we want to calculate D double head, and we can just simply multiply the second half. So which is from here we're going to use the Excel because it's gonna be easier when we use the Excel. Okay, so I constructed some of data into the Excel. So what we need is the alpha head, which was 0.22. Initial value we calculate is negative 4.92, and for double head, so alpha dt is simply actual demand times the alpha. We're gonna use this for the last of them, so we freeze it and scroll down to calculate it, and this one will be 1 minus alpha head, we freeze it again, times into dt minus 1, so it's gonna be previous one, this one. Okay, we can scroll it down. It will come out as 0, but will show up when we do the next step. So here, dt hat is simply alpha times dt plus this one. Scroll it down. It automatically calculates it. So in here, same thing. Alpha hat time, since it's gonna be double hat, we're gonna use the hat 1. Scroll it down, automatically calculate it. And here we use the data here, 1 minus phrase it times, we use the initial value. So scroll down, and this one, same thing, this plus this one. So let's go back to the note. How we calculate demand on 9 OB. It's gonna be alpha hat over 1 minus alpha hat times dt d double hat t. So here it's gonna be 0.22, 1 minus 0.22 times t hat from the period 8 was 7978.25 negative d double hat on period 8, it's gonna be 1885.92. So answers will be $1718.35. We need to calculate it's copy. Oh wait, never mind, I made a mistake. This was a demand on period 9. This was a B hat on 12. Now we need the A hat on 12. I mean, did I say 12? It's 8. It would be 12 D 12 minus D double hat 12, which is gonna be 2 times 9 8.25 negative. And this one is A. Now the expected demand on period 9 will be just add up these two values that we just calculated, which is gonna be 93. We can see that it's higher than demand on 14, so we can say it's about right. And we need to go into the 20s, period 20s. So from here we are going to use the Excel because it's gonna be easier when we use the Excel. Okay, so I constructed some data into the Excel. So what we need is we need the alpha head, which was 0.22. Initial value we calculate is negative 92, and for double head so alpha dt is simply actual demand times the alpha. We're gonna use this for the last of them, so we freeze it and scroll down to calculate it, and this one will be 1 minus alpha head, we freeze it again, times into dt minus 1, so it's gonna be previous one, this one. Okay, we can scroll it down, it will come out as 0, but it will show up when we do the next step. So here dt head is simply alpha times dt plus this one. Scroll it down, it automatically calculates it. So in here same thing, alpha head time, since it's gonna be double head, we're gonna use the head one. Scroll it down, automatically calculate it, and here we use the data here, 1 minus freeze it times, we use the initial value. So scroll down, and this one same thing, this plus this one. So let's go back to the note. How we calculate demand on 9 will be it's gonna be alpha head over 1 minus alpha head times dt double head T. So here it's gonna be 0.22 1 minus 0.22 times T hat from the period 8 was 7978.25 negative the double hat on period 8, it's gonna be 1885.92. So answers will be 1718.35. We need to calculate it's gonna be oh wait, never mind, I made a mistake. This was the demand on period 9. This was a B head on 12. Now we need the A head on 12. I mean, did I say 12? It's 8. It would be 2 D 12 minus D double head 12, which is gonna be 2 times 7 minus 8.25 negative. And this one is A. Now the expected demand on period 9 will be, just add up these two values that we just calculated, which is gonna be 293. We can see that it's higher than demand on 14, so we can say it's about right. And we need to go into the 20s, period 20s. So we're gonna go back to the Excel. From so expect demand under 19 was, say 89. From here we don't know the actual demand, so we're gonna use the expect demand instead of this one. So let's go into 20. The thing is, we have to calculate the remaining expect value for this one. So let's make another column for A hat, E hat. For A hat, it's gonna be 2 times T hat minus D double hat. And this is gonna be this one minus that one. Not this one, this one. Oops, give me the error. That's okay. Okay, let's. This one has to be here. And this will be A hat plus B hat. We're gonna go to the one. So we can say that exit value on period 20, expect demand on 20 will be 34690.85. Let's round it up. All right, there you go. Okay, so this time we're gonna go over the problem number 8. So we need to fill out this chart, and the problem is says we're gonna use 3 months moving average, and the problem is says we need to use this for the weighted value. This one simply means the first month has weight of 0.1, second month has weight of 0.3, and third month has weight of 0.6. So when we sum up this one, it came out as 100%. So we're gonna do the for month 12 because we already got the month 11. So since it's 3-step moving average, we're gonna use the 3 previous one, those 3. So average is 180 plus 210 divided by 3, which is 196.36. So let's fill this one out. Let's use different color. And error is simply difference between expected value minus demanded value. So we overestimated, so it's 34.67. And to get a weighted average, we're gonna do similar one, but we need to use the weight. It's 19.1. This is for demand on 12. This one came out at 200.40. Okay, let's move on to month 13. So this time we're going to use these 3. And it came out as 184.67. And weighted value on 13s. We're gonna do the same thing as before. This one is 178.40. This 186.67. And we also overestimated, so difference is 26.27. Okay, let's go ahead and fill out rest of the columns. So on the 14, so period 17, we don't know the actual demand. Oops. So we need to get the expect demand, this one and this one. So on 17th, we are going to use these 3 values. Which is 199. and weighted value. Which 2, 3. So let's this one out. So there we go. Let's say if we had a month 18, will be the same thing because it's moving average. We use the moving average when it's showing constant. So when we didn't graph it, but when we graph it, we always see that it will behave as the constant. So if you have 19th, then expected will be the same thing. Okay. If you read the problem, it says season, so we might get clue that we have to use the seasonal, but it also says because of global warming, which means recent data is more valuable than old ones. So to confirm this one, we have to graph it, and when we graph it, it comes like this. So we can see this parents. We can make this into the year 1, year 2, year 3. So this will be quarter 1, quarter 2, 3, quarter 4, which means we're gonna use the seasonal. So let's draw the chart. It's moving weird. Oops. Let's drop here 1. It's 35. So first thing we need to find is the average. So average of this 4, it's going to be 35, 25. This one 24.75 and 12.50. So oops. Let's make one more chart. Say T 1, 2, 3. Demand. Unit DT. And T square. We'll say T bar is 2. and the bar will be the 23.83, and sum of dt is going to be 121.25. Sum of t score will be 14. So let's go ahead and use the linear regression formula. To get a expected demand on year 4. You can say average. So let's copy the formula first to make it easier. So we need to calculate P first. P hat first. We already got all the information, so let's put the numbers in. 5. And if we calculate this one came out as negative 10.88. Now we can calculate A. A is 23, negative 0.88 times 2, which is 45.58. Okay, so let's get the T on year 4. It was 45.58. P was negative 10.88. T is gonna be 4. So it's gonna be 2.08. And we had to expect each years. So let's draw a more chart. So P1, 2, 3. We need to weight those. So 35 divided by 34.25. It's kind of hard to see. And for year 2 was 19, 630 divided by 24.75. Year 3 is gonna be 13, 9, 12, 16, and divided by 12.50. Okay, let's calculate those first. Nine 1.11 0.97 0.77 1.05. Okay, now we need to get a period index by getting an average of each course. So average on first quarter will be 1.01, 2.79, 1.20. So we can say that on year 4, expect demand as times 1.04, 79. So it came out to be in year 4, quarter 1, 2, quarter 4 will be 2.11, 1.64, 2.09, and 2.50. Okay, now let's go over the last problem, which is the problem number 10. And the problem in the problem, it says nothing about the exponential or listen data. It says the owner is just happy, don't wanna move elsewhere, which means gonna stay on the same location, do the same thing. Just wanna know what's gonna happen on next year. So as we did before, let's graph it, and we can just looking at the just by looking at the graph, we can just say it's increasing. So we're gonna use the linear regression. So it's going about like this. So let's make one more column here to calculate what that we need. So we need dt and t square. So let's just multiply t times d to get a dt, which is not that hard. So 3,400, 10,500, 13,200, 19,000, 24,900. If we use the Excel, it might be just faster. Okay, so with the average of a t, which is t bar, it's going to be 6.5, and average of d, we'll calculate this one, it comes 3033.33, and we need to, we don't have space, so let's go to the other side. We need sum of dt, which is this huge value, and sum of t square will be 650. Okay, so we first need the b hat, which is sum of dt. Is it minus or plus? Kind of forget. Yep, minus. Okay, let's just plug the value where we calculate everything. So once you calculate everything, it's gonna be easy. So that, and it's 12. And b hat came out to be 146.50. Let's go ahead and calculate a hat, which is d. T bar was 39, 33, 33, negative, oops. P hat, which is 146.50, and T bar was 6.5. And when you calculate this one is 2981.06. Now we have everything. We can calculate the next year. Oh, actually this is by the month, just notice. So end of next year, which will be the D24, not 13. So we're not gonna calculate the 13. We'll be calculating 24th. So let's go and do it. Which so a head plus p head times t. It was 29.6 plus 146.50 times 24. So answer came out to be 67. Oh, wait. 6,497. Let's say it's about 6,498. Issues. So there you go. That was assignment number 1 for IME3261.